Hello, everybody. I wanted to make a video to address some of the errors that I was seeing while grading your module projects, and it was just a little overwhelming trying to explain some of the same things, um, for everyone's work. So I just decided to make a video, which will just explain all of the questions in the module one, project one, numerical check. So we have 10 problems, and they all come from your project worksheet. So I'm just going to go through and perform the calculations required for all 10 of these. So I hope you enjoy it, and let's get started. So the first question dealt with number 4 from the project worksheet. It says the Inca Trail measures 43 kilometers. And given that 1 mile equals 1.61 kilometers, how long is the Inca Trail in miles? And they want us to use dimensional analysis. So we have the initial quantity, which is kilometers, and we have what's called the unit fraction. We'll need both of these in order to calculate this. So to perform dimensional analysis, we have 43 kilometers. And we can create like this little sort of column table looking thing here. And the way we use the unit fraction here is we want to catty corner the units that we wish to cancel. In this case, we used to cancel kilometers, so we want to put 1.61 kilometers diagonal from the 43 kilometers we have above, and we want to put miles just to the side of that unit that we're actually canceling. What this is going to end up doing when we multiply, because what we do is we multiply straight across the top, straight across the bottom. That's how we multiply fractions. The kilometers cancel, and what you end up with is 43 divided by 1.61 miles. And if let me bring up my calculator really quickly. If we go ahead and calculate this, we'll see 43. We'll divide 43 by 1.61. And that's going to equal 26.71 miles. Now, why did I write 26.71 instead of that entire sort of string of decimals? It's because the problem asks us to round to 2 decimal places. So this is our final answer there. And again, that's how we perform dimensional analysis. We'll have several other opportunities to see dimensional analysis performed. So I'm just going to keep going with this. All right, so number 5 says, the first day of the hike you covered 12 kilometers. I'm kind of covering it up here a little bit. There we go. The first day of the hike you cover 12 kilometers in 6 hours. All right. What was your average walking speed in miles per hour? Okay. Now this is how we perform dimensional analysis when we have two quantities that we need to consider. So when we talk about rates are the distance or the change in distance over the amount of time it took you to cover that distance. So 12 over 6 would be 2 kilometers per hour, at least in how they gave it to us. But we need to convert that to miles. So I'm just going to use the quantities that they gave us, and I'm going to write 12 kilometers over 6 hours. We can extend that on out. Now the hours is fine. We're gonna leave it. We're gonna leave the hours because they want the answer in miles per hour. So we're just gonna leave the hours down there, but we are gonna convert the kilometers. And if you remember, they gave us a unit fraction that describes um, miles to kilometers, and it was up here. My mouse will work. There we go. It was here. So we could still use the same unit fraction to convert these kilometers here and calculate and see what our speed was in miles per hour. So remember, we catty corner the unit we're trying to cancel. In this case, it's going to be kilometers. Now that unit fraction said that there was 1 mile equals to 1.61 kilometers. So if we multiply straight across the top and the bottom, like we always do, The kilometers will cancel, and we end up with, let's see, we have 12 over 6 times 1.61. Change that to multiplication. And this is going to be in miles per hour. All right, that's going to be the unit. So let's bring up our calculator and calculate that. All right, so I'm going to say 12 divided by, and put this in parentheses, 6 times 1.61. And it looks like we're walking at a speed of, and this wants two decimal places, 1.24 miles per hour. All right. So again, if we ever have two quantities in place, as um, in this case we had kilometers and we had hours. Um, when you think about a rate, a good thing to, a good way to kind of remember how to deal with rates. Rates are going to always kind of be given in this per that format: miles per hour, price per pound, price per gallon, things like that. So if in this format, this per that, the unit fraction ends up being this over that. Okay, so let's continue. Number 6 says, using the average walking speed that we calculated previously, which is 1.24 miles per hour, how long should it take you to walk to Machu Picchu? Now, we kind of have to look up. Um, we kind of have to look up how long it would take, or how far, what the distance is to Machu Picchu. So let's see. Let's see. Mm, let's do it like this. Um, okay, so we have both. We have the distance. We have the distance of the trail, which is the 26.71, and then we have the our walking rate. So we use these two quantities to calculate how long it should take us. Okay, so the thing about this problem is we have to use the distance formula, and distance is equal to rate multiplied by time. All right, so they want us to calculate time, right? Because they asked us how long will it take us? So if we need time, then we should solve for time. So we're going to divide both sides by rate, and we get that time is going to be equal to distance over top of rate. So we can go ahead and substitute in the quantities that we know. We have the distance being 26.71 miles over 1.24 miles, and this is per hour. Now, how does this look in the sort of dimensional analysis format? Let me go off the side of the page and let's talk a little bit about that. All right, so the quantities that we were dividing, so it's going to be 26.71 miles. This is going to be over 1.24 miles over 1 hour. Right? So this is miles per 1 hour, this many miles per 1 hour. Now, when we divide fractions, a great thing to remember is the keep change flip. So we have 26.71 miles over 1. There's no unit for the 1. We just want to turn this into a fraction. We're going to change our division to multiplication, and we're going to flip or take the reciprocal of our denominator fraction. So here, I'm going to take the reciprocal. That's going to be 1 hour over 1.24 miles. right? And remember, this is going to give us time, and that time is going to be in hours. So hopefully you can see here that the miles will cancel and that you will be left with the unit of time. So the miles cancel, just like we multiply fractions, straight across the top, straight across the bottom. So we should end up with 26.71 over 1.24 hours. Let's bring up the calculator and see what we get here. 26.71 divided by 1.24. And we end up with 21.54 hours here. 21.54 hours to walk from the entire length of the Inca Trail. Okay? And at any point, you can just pause this video and, write down anything that you need. All right, so I'm going to continue to move on here. It says, what is the highest peak in North Carolina? And what is the elevation? What is the elevation to the nearest foot? Write your answer in complete sentences. All right, so I believe the highest peak is Mount Mitchell. All right, so Mount Mitchell is at 6,684 feet. So that's going to be Mount Mitchell. And Mount Mitchell is going to be, I need to rewrite that. Mount Mitchell is going to be at 6,684 feet above sea level. All right, nothing too crazy there. No calculation really required in that one. We just have to look it up. So number 8 says the highest point of the Inca Trail, Dead Woman's Pass, has an elevation of 4,215 meters. Given that 1 foot equals 0.3 meters, use dimensional analysis to convert the highest elevation on the Inca Trail into feet. So luckily for us, we've been doing dimensional analysis several times up to this point. So we can start with the initial quantity, which is 4,215 meters, 4,200, excuse me, and 15 meters. And since we already have a unit fraction, we catty corner the unit we wish to cancel, which is meters, and above it we write the unit we're converting to, which in this case is feet. All right, meters will cancel. We multiply across the top and the bottom, and what we end up with is going to be 4,215 divided by 0.3 feet, and that should increase the quantity. All right, so anytime you divide a value by something less than 1, we're actually increasing the value of that quantity. So if I divide by 0.3, we end up with 1,400. And let me move all this stuff over. We end up with 1,450 feet. All right. Okay, so now we have to look up some temperature. Some temperatures to this is what actually globalizes our course and makes it pretty cool. But number 6 wanted us to look up temperature there, and it actually in Celsius ended up being 11.5 degrees Celsius. But the real trick here was number 11, where we had to actually convert that to Fahrenheit. And I think some people they just they typed this in their calculator incorrectly. So if I wanted to convert 11.5 degrees Celsius into Fahrenheit, I would actually put 9 over 5 in a parenthesis. Then I would multiply that by the 11.5 degrees Celsius and add 32. I think the majority of people, they knew and you know that you're supposed to put 11.5 in there for C, but when you're actually calculating it, there might be an issue with how you represent that fraction. So I'm going to take 9.9 over 5 and I'm going to put that in a parenthesis. And then I'm going to multiply that by 11.5. And then to that, I'm going to add 32. And I end up with 52.7 degrees Fahrenheit. Okay. Something that I use as I take a sip of coffee really quickly. Something that I use to kind of help me make some semblance of Celsius temperatures. I know somewhere around 21 to 23 degrees Celsius is something that feels good. That's like in the 70s, like high 60s, low 70s. And I kind of use the about 21 to 23 as like, hey, this is a really good temperature, like a fall day, like a fall autumn day in North Carolina type of temperature. So like 11 is like kind of getting on the cold side, you know. So let's go down number 13. It says, oh no, we have some tooth um, tribulations kind of going on, and we have to visit the dentist, and we're prescribed an antibiotic, and it has a certain dosage, and that dosage is 7.5 um, milligrams per kilogram of body weight. All right, so and that's that this this unit fraction here isn't super clear, but in general, it's just saying we have to take a certain amount of medicine per kilogram of body weight. So we know we weigh 128 pounds. I don't weigh 128 pounds, but maybe you do. Um, and the antibiotic comes in 250 milligram tablets. All right, so they ask us, okay, well, how many tablets should we take each day if we need to if we need to if we need to sort of you know take the dosage that we were prescribed by our dentist. All right, so the first thing that we want to do is we need to convert our body weight to kilograms, and then what we want to do is um, sort of just determine how many milligrams we need to take, and think about that in terms of um, how many tablets we actually are going to take per day. Okay, so let's go ahead and do that really quickly. Um, and this is every 6 hours, by the way. So if you think about it, like we have to take whatever dosage we're given 4 times a day. All right, so whatever you get for this first initial calculation, we're gonna need to multiply that by 4 because that's how many milligrams we're gonna need to take per day. And they're trying to ask us how many tablets we take per day. All right, so here we go. First thing we're gonna do is we're gonna go ahead and convert our body weight into kilograms. So, as far as pounds here, they're 128 pounds, and 1 kilogram is 2.2 pounds. All right. I don't think they gave us the unit fraction there, but we can look that up pretty easily. I just kind of know this because um, I guess I was in a weight room a lot, and I was always just kind of interested. And also, I played Tekken 3 when I was younger, and Tekken 3 they gave all the characters weights and heights in meters and kilometers, and not kilometers, but kilograms. Also in the Olympics, they do that. And so I was always interested in, okay, what weight class are they in and what weight class am I in, type of thing. So let's go ahead and calculate this. All right, and let's just see. So there should be 128 divided by 2.2 kilograms. All right, let's bring up our calculator. 128 divided by 2.2. A person that is 128 pounds weighs 58.18 repeated kilograms. Now, I'm going to kind of keep this on screen because I kind of want to use that. Um, I kind of want to use that number there. So we need 7.5 um, need 7.5 milligrams of this medicine per every kilogram that we have. So I'm going to go ahead and multiply that by 7.5. Okay, so now we end up with 436. All right, so 436 point 3636 repeated sort of thing. That's going to be the amount of, that's going to be our dosage every 6 hours. All right. We need that many milligrams every 6 hours. So if we multiply that by 4, it will give us the amount that we need per day. And since these tablets come in 250 milligram tablets, if we were to divide this by 250, it would tell us how many tablets we need to take. And it's looking like we need to take right at 6.98 tablets per day. And I mean, maybe you would be really good at determining, breaking off just a little bit of one of them tablets so you could have that much, but likely we're going to end up taking 7 tablets per day. All right, so let's review that real quick because there's a lot of moving parts. I'm going to sip some more coffee really quickly. Hmm. So, first thing we did is we converted our weight into kilograms. Now, I could have rounded here, but I chose to kind of leave all of this sort of information behind the decimal just to make the calculation a little more, um, just a little more accurate. Now, here, I took this number and I multiplied it by 7.5 because this is my body weight in kilograms. And this is how much of a dosage I need per kilogram in body weight. So if I multiply these two things together, it will give me 436.3636 repeating, so the milligrams every 6 hours. Now, since there are 24 hours in a day, I went ahead and multiplied this 436.36 repeating number by 4 to account for 6 hour periods in 24 hours. And this right here, this 1745, this gave me the total dosage that I need of this medicine per day. All right. Now, these tablets, they want us to express the calculation in tablets. These tablets come in 250 milligram tablets. So if I take this quantity, again, this is in milligrams, this is the total amount of milligrams of medicine I need to take per day. If I divide that by 250, it will give me the total number of tablets that I need per day. This asks us to round to the nearest whole number. The nearest whole number to 6.98 and some change is going to be 7 tablets per day. Okay, so I think on the next question we're using what we learned here. It says if you need to take the pills for 5 days, how many tablets should the pharmacist give you when she fills your prescription? Um, well, we need 7 tablets per day. So 7 tablets per day. All right, per one day. And if we're going to take it for 5 days and we're going to multiply that by 5 days, the days end up canceling and we end up with 35 tablets for that whole duration of that, for the entire duration of that particular dosage. Okay. In question number 15, I think question 15 was the last question. Yep, it was the last question in our numerical check. It says recently the number of visitors to Machu Picchu was limited to 2,500 visitors daily. The area has about 13 square kilometers, and it wants to calculate the current daily visitor density in daily visitors per square mile. All right, so population density is given by the amount of people over the square area. So that could be a population density in square miles, square feet. Ooh, not too many people can stand in a square foot, but in any case, we can perform dimensional analysis. So we already kind of have our sort of quantity. It's going to be 2,500 people over 13 square kilometers. Now they didn't give us, um, they certainly didn't give us um, the amount of miles, square miles that are in square kilometers, but I do know that above earlier we got that 1 mile is equal to 1.61 kilometers. So we can use that to our advantage, and I'll show you how we can do that. Let's go off to the side. So we're gonna have two squares. One's gonna represent kilometers, and one's gonna represent square miles. So we'll say in a square mile, so 1 square mile, that's gonna be given by 1 mile per 1 mile, times 1 mile, right? So that's how we get our square mile here. Now, kilometers, if these squares are the same, we're going to assume they're the same. This distance, the distance of the sides, instead of being 1 mile, are going to be 1.61 kilometers times 1.61 kilometers. Oh. And we don't really know yet how many square kilometers exist inside that area. So we're going to bring up our old reliable 1.61 times 1.61. And what we can get is that we can create our own unit fraction in that, 1 square mile is equivalent to 2.5921 square kilometers. And we can use that unit fraction to help us with this question here. So we'll come up above and we say, all right, we're going to catty corner that 2.5921 square kilometers over 1 square mile. So we can convert this. And let's see what we got going on here. So these cancel. And we're going to multiply across the top. We're going to multiply across the bottom. All right. And let's see what our population density ends up being. All right. Get that calculator out. This ends up being, what's that? 2,500 times the 2.5921 over 13. What's that equal? Let me move this up so we have some room to write it below. Oops. All right. That's going to end up being, bring up that calculator. I don't know when I do not know when my iPad is messing up today, but it's okay. We shall work with it the best we can. All right. So I'm trying, y'all. Let me just do this. Here we go. Apple always claims to be the best, so it's time to actually show what's going on. I don't know what's happening. 2,500. And we're going to multiply that by 2.5921. All right, then we're going to divide that by 13. And they want us to round this to the nearest. So let me just write down while I can before, my iPad just decides to quit on me today. So that ends up being, oh, I forgot to write it down. 498.48. All right, that's our population density. And that's going to be people per visitors per square mile, but they want us to round to the nearest hundred. So the nearest hundred is going to end up being 500 people per square mile. Look, I hope this helped. At any point during the video, feel free to, rewind, go back and see any of the calculations or how I performed any of these. And let me know if you have any questions when I'm grading these. If you miss something, I'm just going to refer you to this video. And I covered everything here. So just let me know if you have any other questions. And I hope you all have a great day. Peace.